that points away from the center. So the only choice we have here, we can't decide the direction of r hat, we can decide the center. Once we figure out the reference point, whatever the center is, we can then deal with r hat. So in this case, the center is right there. R hat would be a vector pointing away. Negative means the opposite direction, towards. Questions to hear?
So negative r hat means a unit vector that points towards the center.
Yes.
So, and that's for circular acceleration?
Centripetal.
What does that mean?
All right, I'm glad you asked. That's a nice segue into the next thing I was going to mention. The formula for centripetal acceleration. So let's talk about the word centripetal. From the root center, pet, or pedal. I guess that's just makes the adjective. The PET, seeking. What word do we have in English that has PET in it, which also comes from the root meaning to seek?
Petition?
Say it again?
Petition?
I believe so, not the one I was thinking of, but yes, that works. And competition as well. Two teams come together to seek each other out. Let's contrast that with the other word that is usually used. And possibly the last time we used this word.
Centrifugal. Center.
Center, yeah. And then the fugue part, fleeing. What word do we have in English that has F-U-G in it? That means fleeing.
Fugitive.
Yes. There's also a common Latin expression, tempus fugit, which means time flies. The acceleration is toward the center. That makes it centripetal. It is possible to use centrifugal or centrifugal, the second one. It's possible to use this properly. It is a legitimate word. It's just that it is so misused. I would recommend that you don't use it in this class. .99% of the time when the student mentions these words, this is the one that they want. I'm going to erase this. Any questions before I erase it and we never talk of it again? Now we might. All right, centripetal or centripetal, depending upon how you were raised. I think centripetal is more the American pronunciation, and centripetal is more the British, something like that. The advantage of centripetal is I think it flows better off the tongue. Centripetal, it's much less confusion about which word I say. Now, since force equals mass times acceleration, if that's my acceleration, that means the force would just be the mass times this. And mass times that would be a centripetal force. So centripetal force is the force that points towards the center. So as I was swinging the stopper around, swinging it that way, overhead view, it wanted to go this way. At that point, it wanted to go that way at that point, that way at that point. But something was keeping it in the circle. Every time you tried to get out, something just pulled it right back in. Godfather 3 reference, for those who missed it. And that thing that is pulling it in is the centripetal force.
So for every time that I wanted to exit, there was a force pulling it back in.
there has to be some force pulling it back in, because naturally, by nature, that wants to go into a straight line. If it's not going in a straight line, there's gotta be something causing it to change its path. And that is the centripetal force.
So into words, centripetal force is the force that keeps a center-seeking object within the parameters of the spin.
I think we can simplify that. The centripetal force is the force that allows an object to change directions.
Oh,
If you're traveling in a circle, the math's just a lot easier, but if I'm on a windy, curvy road, it's still centripetal force, it's just, the magnitude is not constant anymore.
and so you said just multiply that equation by mass?
Mass, yeah, F equals ma. So when we do our equations of motion, we'll have, if it's traveling in a circle, that acceleration will be centripetal. We'll plug v squared over r in for a, and whatever the total force is, that is the centripetal force. Centripetal force is not a new force. It is going to be some combination of the ones we've already done. So, for example, when I was swinging this around, we'll do a side shot, and it's going around like that. There were two forces acting on it. There was, at least attempt to put it in the same direction. There was the tension acting this way, and there was the weight acting down.
But so it's not a new force, it's just a combination.
Yeah, some combination. All right, so where is the center? So from this point of view, in which direction is the center of the circle it's traveling in? Point with your fingers. In which direction? It's going to be somewhere from a side view.
Oh,
So we got,
Like if we're spinning this way.
yeah. So you're going at, say you're going straight and you're going at an angle. Is that Ali, you're going that way? And Ibrahim, you're going that way? And Jack,
I think it's sideways.
that way?
Yes.
And we got another that way.
and now hold on, are we looking at it from, so that diagonal line that you've drawn is really representing a straight line?
Wait, this diagonal line, that's the string.
Oh,
So therefore the tension is along that line. So you're now changing your mind. Anyone want to put an argument in for this? Anyone put an argument in for that?
it's because it's traveling along that path. So
And it is. The center of the circle is that way. That is the direction of acceleration. Take it one step further. We did the force diagram. We've now identified the direction of acceleration. Our coordinate system. One in the direction of acceleration, I'll call that I hat, the other one perpendicular to it. Which of these would we have to break up for the decomposition phase?
I want to say the tension, but I think it's probably the weight. Because or would we do both? Do
The
something.
question with decomposition, the question is any vector that is not parallel or perpendicular to my axes.
Then it'd be tension.
Yeah, you're indeed. Your gut was right. It is tension. We're going to break tension up into its components. There's part of it towards the center, part of it's up. This angle here is theta. This becomes the tension times the cosine of theta. And this is the tension times the sine of theta. That is getting worse and worse. I don't like that big anymore. I have weight acting down. I have tension sine theta acting towards the center, and tension cosine theta acting up.
why isn't it tension, why is this the sign instead of this being the sign?
Oh, you're right. Cosine. Sine. Thank you. So, the centripetal force is that. Tension is not the centripetal force, it's the horizontal component of the tension, which is the centripetal force. This counters out the weight. So if we did our equations of motion, I'd have Ft cosine theta is equal to mass times, I'll put a little c there to indicate its centripetal acceleration. And then I have F sine theta minus the weight is equal to 0. Because it's not accelerating up or down. And so I have F cosine theta equals m times, now the substitution phase, I don't have a formula for tension, I do have a formula for weight and centripetal acceleration. So this is v squared over r, and this is Ft sine theta is equal to mg.
So eventually we get the tension times sine theta equals mass times gravity, constant of gravity.
Just say time, just say g, but acceleration due to gravity. At this point, then comes the question of what are you actually trying to find? Not trying to find the acceleration per se, like we have been. Typically, you're either trying to find the speed or you're trying to find the angle.
So in a problem like this, with this diagram, how many things do you need to know to find out the other things? Like the last thing you needed 3 things.
Are you asking from this point of view or from that point of view?
I was talking about the big diagram overview.
Well, for a single object in a 2-dimensional problem, I'm going to have 2 equations. And so at most 2 unknowns. That's what, it's not exactly what you're looking for. It's not as simple as, if you know these 3 things, then you know everything else, because there's too many variables at this point to narrow down like that. You can, not know 2 things, or not easily find 2 things. All right. Just as a teaser, something to noodle around in the brain over the weekend and make you think, oh, I can't wait to find out how this happens. This is also equal to m omega squared r.
What is that? A W?
It's an omega.
Okay.
It's a lowercase omega.
Oh. Okay.
Uppercase omega looks like the horseshoe.
Yeah. I'll never confuse that with the W.
Yeah, that's some students will call it a W till their dying day, but is an omega.
Can we use?
That's a W.
Can we use?
That's an omega. If you call it a W, I will look at you askance.
Can we look at the W and say, and just write it as the capital, or no?
Or is it different?
No. Well, there are certain symbols that are like F for force. If you want to use F for acceleration, then you have to define it.
Okay.
Lowercase omega, this is angular speed, which I almost went into before.
Yes.
Anyway, the clock says it's time to go. I mean, we could just, I know all of us just want to keep going on forever, but just in case somebody else has something else to do. I could keep going.